In this video, let us set up an interactive system to control a servo motor. We are using two of our products, Automator Interactive, which is our PC application software with visualization tools, and T7000P, which is our signal generation and acquisition hardware. Here is a preview of this demo. Based on the knob position of knob control widget, position of the servo motor changes, and feedback from the motor is displayed in the circular dial widget. We have a follow-up video which demonstrates the full automation of servo motor testing with the click of a button. The link for that video is given in the description field below. Note that the purpose of this video is only to demonstrate the usage of our products. In case you are new to our products, please visit our website for more details. Let us get started with the high-level connection diagram of this demo. Here is the servo motor. And this is T7000P, which is connected to the PC with Automator via USB. The servo motor needs 5-volt, ground, and a pulse signal. 5-volt is provided by a DC-DC buck regulator. And the pulse signal is for controlling the position of the motor. This signal is connected to P01 of T7000P. The servo has a feedback voltage which is dependent on its position. This feedback line is connected to AI1 of T7000P. Here is the actual setup. And this is the servo motor. This red wire is the 5-volt line coming from the regulator. And this black wire is the ground. This blue wire is the pulse signal which is connected to P01 of T7000P. This green wire is the feedback line, which is connected to AI1 of T7000P. T7000P is connected to the PC using USB. Next, let us set up an Automator Interactive project. Here, the device T7000P is already added and is set online. Unlock the project to add the widgets. Now, open the widget tree. The easiest way of generating pulse-out signal is by using the pulse-out widget of T7000P. Drag and drop a pulse-out widget, an analog-in widget, and a status box widget. Let us also place a graph widget just to see the transitions of some of our signals. Resize as needed. Lock the project. For pulse out and analog-in widgets, select the device to which the widget events need to be directed. For analog-in widget, enable AI1 to start the acquisition of feedback signal. For status box, select the signal to be displayed. And select the signals for the graph widget. Set the channel in the pulse-out widget as per the connection diagram explained earlier. Change the frequency to 50 Hz. The default duty cycle can be left at 0. Here is the Python code in the device interface file that converts the analog input voltage to servo motor position in degrees, which will be displayed in the status box. We are ready to control the motor. Now, turn on the pulse-out widget. Change the duty cycle of P01 to change the position of the motor. See the servo position display on the status box widget. So, we achieved the goal of controlling the servo motor. Let us use much more user-friendly widgets. Drag and drop a knob control widget for controlling the motor and a circular dial widget for displaying the speed. Resize and rename the widgets as we wish. Right-click and configure the knob control widget and the circular dial widget to change the min value to 0 and max value to 180, which corresponds to possible servo motor angles. For the knob control widget, select the device to which the widget events need to be directed. For the circular dial widget, select the signal to be displayed. As the user moves the knob, its position information gets passed on to the corresponding device interface file. The Python code in the interface file translates this position information to duty cycle value. And this duty cycle value is sent to the respective pulse-out channel of T7000P. Note that the frequency is hard-coded to 50 Hz. With this code in place, the user can change the knob to control the motor position. As we change the position of this knob, we can see the change in motor position in the circular dial widget. The graph widget plots the real-time transitions in the signals. The signals are also logged into a file. This feature is helpful in case user needs to do some kind of post-analysis. This completes our demo. Hope you enjoyed this video. Setting up an interactive system or a full automation system is very easy and affordable with our products. We do have plenty of other example videos on the usage of our products. Thank you for watching. For more information, please visit us at www.texarsystems.com or contact us through phone or email.